A very good morning to all of you. On behalf of Department of Civil Engineering, College of Engineering, Kidangoor, let me welcome you all to the second day of our faculty development program. Expert for today's starting session is Padma Shri Dr. G. Shankar sir. Let me welcome our head of the department, Dr. B.V. Matthew sir, for a brief introduction about our expert. Matthew sir.
Honorable Padma Shri Dr. Shankar sir, my dear faculty members and participants for the faculty development program, a very warm good morning to all of you. Today I am privileged to introduce a special speaker for our faculty development program. He is none other than Padma Shri Dr. G. Shankar. First of all, welcome you, sir, to this FDP session.
Thank you very much. Thank you very much. Yeah.
Let me give you a brief introduction of our resource person. He's an architect who has done his B.Arch from Kerala University and MS from Birmingham School of Architecture, UK. And he has got his doctorate from University of Asia. He's the founder chairman of Habitat Technology Group since 1987. He is the chairman of National Committee to frame disaster management and mitigation design specifications set up by Government of India. He is advisor to AICT, Ministry of Rural Development, Government of India, CSIR, and a number of important such bodies actually. He is a consultant to Government of India on Sri Lankan rehabilitation package in the year 2010-12. He was actually okay. He is the team leader, international evaluation team for disaster areas, Sri Lanka and Indonesia, Caritas International. He is international director of Architects Sans Frontiers, headquartered at Paris, France. He is president of South Asian Coalition of Community Architects. He is consultant to Government of Orissa and Government of Uttar Pradesh. And he was awarded Padma Shri in the year 2011 in the field of science and engineering. Then he has won the Laurie Baker Award a number of times. And there are many more things to talk about him. There are a number of international conferences in which he has participated as resource person, and many more things to tell regarding him. I will stop describing his achievements and degrees with this, but I would like to add a sentence regarding the person. He's a person in whatever he designs or he makes. He has a thought for all the persons, from right from the child to the eldest person that is going to use that facility. He has got a, you can say, a kind soul and a noble heart to accommodate the concerns of the weak and the downtrodden. And he has been tirelessly working for the upliftment and well-being of the least fortunate people of our society. I respectfully welcome you, sir, once again to this session, and I request you to take over the session.
Thank you very much for those glorious words of introduction. Thank you very much. And it's my privilege to address an august audience like this. I believe that the people in front of me, listening to me, are all teachers. Basically, they are all teachers from various parts of the state, various parts of the country. And it's my privilege to share my thoughts during the stressful times. I said stressful times. You know, we are actually going through a period of upheavals. We are going through a period of uncertainties, and stress levels are, building up. Whether you are in the building industry, whether you are in the teaching faculty, the stress levels are slowly building up. And as you know, building industry is one industry which has actually been right in the forefront of industries that actually got kind of thrashed during these stressful times. Because there are a lot of reasons for that, but we are actually going through a huge stressful time, people in the industry, architects, engineers, and the rest of them. But having said that, I've been working in the disaster mitigation sector for the last 3 decades across the world. And let me tell you with such conviction that each disaster actually teaches us, leaves very, very important lessons to us. Each disaster is an opportunity for us to learn, to look at ourselves, to contemplate, to meditate, and find out answers. If you can call this pandemic times as a stressful time, a disaster time, pandemic times are actually leaving us very, very important lessons when you're talking about designing the building envelope, designing the shelters, designing buildings, etc. And construction industry is, as I told you, is going through several challenges, and there are many important takebacks, which, as a faculty members of this discipline, you should actually take it into these things and put it into the teaching curriculum, because students are all stressed, and tell them that disaster, it might remain with us for some more time because viruses are not going, but tell them that there are several unique opportunities that are appearing on the horizon, and you should latch on to them and put them into focus. Having said that, what is the main thing that has come forth during the stressful times as far as building systems are concerned, the challenge of civil engineering, etc., etc.? What is it that that is the biggest, probably the take back when you're talking about these pandemic times? The biggest take back, I think, the biggest takeaway as far as people like me are concerned is the awareness, the intimate relationship of environment with the people and the building industry. I say it with a kind of conviction that I hope you should share. What is it that I'm trying to tell you? My dear faculty members listening to me, you should actually have some of these statistics ingrained into your heart, because you have to talk not only with passion, you have to talk about this with some compassion too. What is it that you should take back? The very critical relationship of architectural design, the building envelope design, the activities happening in the built environment is, I'm making a huge statement, a brutal statement, is primarily responsible for the climate change that's happening. Building industry and climate change, when I say that, I'm making a huge statement saying that the undesirable activities happening in the building sector are primarily responsible for the climate change. Can you make the link between these? I'm talking about a few linkages and connectivities that you should listen to. We are actually falling short of energy, we are falling short of some natural resources. Why this is happening? Let us look at one natural resource that we have, huge natural resource that we have, water. As you know, Kerala a few years was a water-rich state. We had 44 big rivers, a few lakes all around, a few of them freshwater lakes. There are a number of rivulets that were flowing through the state, hundreds of rivulets that were flowing through the state. We had large fields, rice fields and the rest of them, which actually carry a lot of water. But I still remember as a young child when I was beginning to travel in the trains, I still remember when I was probably 15, 16, the first time I was getting into the trains in the state, I could see slowly packaged water being sold. And I was wondering, water is state, flowing river, water distribution system was so efficient, and why should people buy water? But now I realize we have come to a stage where water everywhere, but not a drop to drink is the situation. All the 44 rivers in the state are drying up. All the rivulets are being completely kind of filled up, and the water source is no longer there. The freshwater lakes are being polluted, and the area of catchment is slowly coming down due to many reasons, including undesirable activities happening in the tourism sector. I don't want to go into that, but I want to leave a very important statistic with you. What is that? Just look at the water usage in our toilets, faucets that we use to clean ourselves. Take out flush out the dirt from our toilets. Believe me, in a country where water everywhere, but not a drop to drink is the situation, we are using an amount of 5 billion liters a day. Can you believe it? I mean, I am civil engineering teachers, I'm sure you will comprehend. I can comprehend that figure because I'm not very good in mathematics. But I'm telling you, 5 billion liters, 5 followed by so many zeros, is being used in a toilet to flush out the dirt. Water everywhere, but not a drop to drink in situation. Likewise, a lot of manipulations, dilutions are happening in terms of usage of materials and technology. That is why for the last few years, I mean, although I know we don't have much options to build, I've been talking against the overusage of cement and steel for one reason. They are energy intensive materials, in the sense the production process are still outdated, obsolete, and they still burn a lot of energy to bring out the product. Last 1 century, we have not really improved the production process of both these materials, but we can't get away from them because these remain as primary building materials. The whole question, at least in the residential building sector, can we go in for alternate technologies, alternate materials, is a question that probably we'll deal at some other session, not in this session. But what I'm trying to tell you is the energy crisis there. And energy crisis due to the bad usage of some of the building materials that take a lot of energy. 32% of the building, the energy that is being produced in this country is being used in the pre-construction phase of the building. That includes embedded energy and the rest of it. I don't want to go into the details of it. But unless and otherwise we look at energy efficiency, there's no scope. So what I'm trying to tell you is the world is beginning to look at sustainability as the only way out. Pandemic times really underline the need for getting onto that bandwagon of sustainability. We are losing options, and my dear teachers of civil engineering, please tell the students that times have come and this is the only option available in front of us. Looking at ozone depletion, looking at carbon emissions, looking at poison spreading all over, looking at toxicity, looking at pollution. And another little point that I want to bring in before I actually get on with the subject of traditional idioms is one should also look at air index, air quality, indoor air quality, which is not a term being used recently undergraduation level. We call the graduation level as there's a misnomer when I say that it's an undergraduation level, but that's a degree actually. In English, that's the right usage, I think. A lot of you have to tell the students the indoor air quality inside a contrived air conditioned space is much more dangerous because it contains 100% more pollutants than the atmospheric air and things like that. I don't want to go into the details, but indoor air quality is one thing that the stressful times have brought forward the quality of indoor air, because we are now sentenced to live indoors. And if you can't really, civil engineers, if you can't get healthy interiors, then you will be morally responsible for the life of the inhabitants. How do you make it is a very simple this thing. Ensure cross ventilation, open the windows, let the air come in and blow away the dust and things like very simple solutions. Technology-wise, material selection-wise, there are many solutions. What I want to tell you is that these solutions were there in our traditional idioms. This is what is surprising, isn't it? This is what our forefathers used to tell me without the template of scientific advances and engineering advances. These were, I mean, it's a very interesting connectivity between the traditional idioms, I mean, both in architecture and civil engineering, and the traditional idioms in building sciences, and a few things like that. With that, let me actually go into a presentation which will be more structured, because we have to probably wind it up in another 50, 60 minutes, and then we'll go ahead a little bit with the discussions and things like that. So let me just switch over to the presentation. Yeah. Can you see the slide? The moderator?
Yes.
Okay. Today, actually, I am going to talk about local things only. I mean, whether it is local materials, whether it is local design solutions. I'm talking about indigenous solutions and the innovation part of it, which is very, very creative. I mean, if you want to tide over the crisis of the present times, I mean, pandemic times, the only way, I'm telling you with such conviction, let me tell you, the only way of bridging this gap, bridging this huge crisis that we are going through, is to look at innovation. Let me reiterate, innovation is the innovative strategies, innovative building engineering strategies, the only way to tide over the crisis. I mean, don't call it a crisis, challenge, which we will overcome together. I've been a skeptic for a long time, but now I'm a very strong believer in things, in the possibility of things. And today, I mean, let me just start this thing with looking at how buildings actually responded to the locality. I don't know whether you have heard of, people out there have heard of organic engineering and organic architecture. Organic architecture and organic engineering talks about soulful expressions of building. Let me expand on that particular concept of organic engineering and organic design. How does a building respond to the locality? I still remember, a few years back when I was reading Khalil Gibran, the famous poet, Lebanese poet, who actually lived in United States for most of his lifetime. He had mentioned about the journey of a building. He said, there's a building, in the poem, there's a building which is in an urban, chaotic situation. And the building actually dreams about making a journey to a hilltop in the evening. A very beautiful journey of the building from an urban landscape to a rural setting. Now, the poet says the building should not be an anchor. Very, very important. Please, if you can note down, the building should not be an anchor. I mean, when I say that, building should have rootedness to cultural idioms and cultural landscape. I say it with such care and conviction. When I make a statement, I'm very convinced about the possibilities, the questions that can come. Now, if the design of a building, whether it's the engineering design or the architectural design, if the design of the building is not local, then people will actually dump it in the waste baskets. I mean, you will not survive. When I see the contemporary buildings, across the landscape of Kerala, this is what all chassis colors, jarring kind of vocabulary of building materials. When I was a student of architects, I still remember basic principles of architecture were rhythm, harmony. It was talk of balance, asymmetry, symmetry, proportions, and a lot of qualities like that. Everything is being taken for a ride, and I feel very sad about it. But let me come back to the basic organic position of a building. Is very critical. We call it in a different way. We call it as a site orientation. When you design a building, this is what I do. I look at the sun. I look at the sun. I look at the wind direction. I look at the vistas. I look at the soil condition. I look at the accessibility to services, power, water, rest of it. I look at the contour. I still belong to a probably an old brigand of people, environmentalists, who still believe that building should belong to the site. When I say that the building should belong to the site, I mean it should hug the profile of the land. If it's a mountain, for instance, the design should be very critical to the mountainous terrain, It should hug the profile of the mountain. The building, let me make a statement which I hope you will take down. The building should not be on a mountain. The building should be off a mountain. These are not my words. This quotation is actually from one of the books written by Frank Lloyd Wright, who is supposed to be the father of organic architects in the world. Frank Lloyd Wright, who the American architect, who said the building should belong to the site. When he further expanded, saying that when you are getting a design to build on a mountain, it should be off a mountain and it should be on a mountain. Like that, all the parameters that I've been talking about in terms of site location, the orientation of building is very, very critical for many reasons. When I say that the building should belong to the site, what do I mean? I mean cost efficiency, foundation cost and the rest of it. I don't want to go into the details. You can ask me questions how that is going to be, but I'll answer that during the session. But then it's not only the cost efficiency. It talks about energy efficiency, it talks about climate appropriateness, and it very critically talks about eco-sensitivity. Kerala cannot now go on with this kind of rampages that's happening. Kerala cannot go on like this. All the rice fields are being flattened, all the mountains are being flattened. Kerala cannot go on like this. We flatten out everything. The disasters will come back in such force. And I've been working Puthamala in 2018, Kavadapara in 2019. All this is happening because of a new phenomenon. I'm very particular that civil engineers should listen to that. A new phenomenon is happening in Kerala. It's not landslide, my dear friends. It's not landslide. It's not soil erosion. It's a new phenomenon called soil piping. You should ask your geologist friends to know what is meant by soil piping. Soil piping basically happens when you disturb a mountain or a plain land by building unsustainable buildings. I don't want to go into the details, but soil piping is going to devastate Kerala in the calendar. As you know, as we all know, this climate change is going to be a calendar event, and soil piping is going to be of a devastating nature. Kavalappara, it was soil piping. Puthumala, it was soil piping. And if you continue these rampages on the Mother Earth, if you get a slope, build it according to the dictates. It's for an architect, engineer to come out with innovative solutions, talking about disabled people, not having to really going for multiple levels and things like that. How do you access if you have a cellar, can you easily access it without having to really go through a step and things like that? Is going to be all site specific, but this is a concern that you should have. This is more critical for a state like Kerala because sun and wind are very critical for a healthy life inside the house. And as we all know, you and me are sentenced to live in our houses for a good part of our life. Unless you look at the sun and the wind, unless you orient the building in such a way that we get westerlies into the building, unless you actually look at the cross ventilation and the lighting part of natural light, I teach in many Western universities, especially in Sweden and Norway, where you don't see sun at all. Most of the year, you don't see sun at all. It comes like a moon. In Norway, I still remember. It's actually called, Norway is called Land of the Midnight Sun, and sun comes out at 3 o'clock in the afternoon. And you can look straight at the sun, and it looked like a full moon. I mean, that's it. Cold sun. I've never seen cold sun in India, especially in Kerala. We have such brilliant sun here, and if you can get natural light in, at least in the daytime, you don't have to put electricity on, lights on, and yeah, I mean, these are the things that I wanted to talk to you. Now, let me also, I mean, I'm talking about traditionally, for a minute, like a prayer, just read this thing. I want each of you to read this because it's beyond shelter and function. Let me tell you that it's beyond shelter. And house is actually, we talk, I mean, this is, I've been quarreling all my life with, you know, mandated houses that are given by the government, you know. You have heard some of my criticism against some of the big housing schemes that are happening. You know, we actually, who are we? Are we mandated to decide about the requirements of the poor people? Are we, when you're talking about 300 square feet houses, 400 square feet houses, and whereas you live in a 2,000 square feet house, you have the moral authority to teach others. What do you really mean by a shelter? I mean, last few days, 3 days back, I was in Kasaragod, you know, looking at some tribal hamlet, and government has built 1,600 houses there in that particular hamlet. Very few takers, less than 200 people, 200 houses are being actually taken. In all the other, they just abandoned the building. It's not culturally appropriate. They put the animals in and they stay outside. 400 square feet houses. So, I mean, are we mandated to, I mean, it was our Prime Minister, let me also make it very clear, it was our Prime Minister, the first Prime Minister of India, Jawaharlal Nehru, who talked about this fallacy of we deciding, engineers and architects deciding, and the ruling class, you know, deciding about the stipulated area for the poor people. My dear friends, I mean, we have got a huge legacy, architecture, building, everything, we have got a huge legacy. Where in India, where in the world, I'm making a huge statement again, where in the world can we set such legacy, especially in building sciences? A legacy built on mathematical calculations, legacy built on our, you know, astronomical positions, legacy built upon our old knowledge faith. I still believe when you talk about traditional building system, the research product, it's a pure research product out of people's will, people's experiences, research product that has come out of 1,000 years of research and development. So that is why I call, it's also the reflection of immaterial dimensions like culture and ideology. Buildings also reflect not only what we are able to accomplish, but what we are able to imagine, dream, or even fear. I mean, that's a beautiful this thing. I really like this thing, and that was India. That was the legacy of India. When I read the newspapers, Chak De India, you know, when the women hockey players won some salvage, some pride in beating, you know, a good team, Australia, to enter the semi-finals of Olympics. This was Chak De India. You know, where else can we have such knowledge systems, especially in the building industry, based on pure mathematics, based on the cultural idioms of the state, and based on very strong traditional system, based on local knowledge, nowhere else in the country, nowhere else in the world. I mean, this is, I'm saying it with such conviction because I work across the world. I projects across the world. And that is why I'm saying with such conviction that the legacy of architecture in India, vernacular architecture in India, legacy of vernacular building sciences in India, building systems in India is something, the knowledge base is unparalleled, based on pure mathematics, based on sun and wind movements, based on such, you know, takes when you talk about even cultural appropriateness and things like that. So, I mean, it has been this is what happened. I mean, when you really look at the profile, the mountains, you know, we have mountains, we have midlands and the coastal line in Kerala, in the state. Our buildings used to respond to that. The buildings that were built in Kanjanappalli high-range area were distinctly different from the buildings being built in Tangasheri or Puvar in Trivandrum. It was a manifestation of the dream. And we had 4 classes in the beginning. We were talking about Kshatriyas, we were talking about Brahmins, we were talking about Shudras, and we were talking about Vaishyas. Vaishyas had a storeroom to store their grains and things like that. Kshatriyas had a room for keeping the arms, and Brahmins had a puja space to do the pujas for the deities. And where else? This is why I say it with such happiness. It's an architecture of happiness. It's an architect. It's the building science of happiness, my dear friends. And this is, what we learn from the traditional leaders is to strip away all the egos in building sciences. This is what is very important. When you pass through the main road, buildings have unfortunately become symbols of pride and the rest of it. Symbols of what I call in Malayalam as ahangaram. Very pretentious buildings. You want to show your power. Buildings have become symbols of power and things like that. Strip away all the ego in building science and all the design theory. This is what, when you see the old buildings, you feel connected. You really feel the coolness. Just looking at the building, it doesn't disturb you. Instead, you'll have a good feeling. It's not nostalgia, my dear friend. This is probably somewhere connected to the cultural landscape of India. Cultural landscape, your cultural landscape, and that is why you feel that buildings are very good to look at. And now, if you call yourself as an engineer, how do you react to this statement? You are mandated to actually build. What is architecture? What is building engineering all about? It's conditioning a space for human comfort. Let me come back to that statement. I'm not looking at romantic, quotations. I'm just telling you that conditioning a space that is available for human comfort is the spirit of building in this world. Conditioning of space for human comfort is this thing. And you're actually providing shelter. You would like to design a place to sleep, a place to meditate, a place to listen to music, a place to sing, a place to dance, a place to read, and things like that. When you do that, you are actually providing a shelter for the man. And it's not about egos and pretension. That is why the traditional architecture is so simple and so good. Let me also take you to some of the pictures, some of the visuals, because these visuals are very critical for you to understand things. You can see this Nadumuttam, internal courtyard, in a very traditional building. The key journey is about flowing through space. When people come to me as an architect for building houses, this exactly, I actually take them on a journey. It's a journey, trying to discover yourself, trying to explore. And that is why people find it probably more attractive. That's how I'm surviving. That is exactly how I'm. Hello? 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 Hello, can you hear me?
Yes, sir. There was a disturbance.
There's some disturbance. There's somebody has to, mute themselves.
Yeah, we are muting all the participants. Okay.
Okay, and please mute because otherwise I will not be heard. So it's about the flow through the space. It's about journey. Look at this particular thing. It brings in light, with happiness also. So this is very important, and this is what traditional idioms always talk about. There are 3 elements. Again, I'm taking your engineering minds. I know you're all civil engineers, teachers, and this is very important. If you want to get tuned to what I'm trying to talk about traditional building systems, this is very important. This particular journey is very important. It talks about space, time, and energy. It talks about Agasham. It talks about Kala, and it talks about Shakti. Space, time, and energy. Let me start with it. The space. This is what I told you. What is the basic definition of a building? Is you are creating a little space out of this infinite space, a little space for you and your family to be happy, to be content, to have some peace for you to sleep and dine and cook and things like that. All the things that are necessary for a living. So when you do that, you have to do it judiciously. Sky, as you know, is if I really use the flowery language, it's kind of omnipresent. I mean, it doesn't have boundaries. It's, you know, it's a thing beyond boundaries and without boundaries. You know, sky is infinite. Space is also infinite. If you make it into a smaller this thing, then it becomes Agasham. I still remember, you know, as a young boy, you know, I was reading Amrita Preetham, and Amrita Preetham, I don't know whether the seniors in this group will realize that she was actually married to Sahir Ludhwanvi. I mean, he was the foremost lyric writer in Hindi films. Sahir Ludhwanvi, one of the most beautiful film songs that we hear in, you know, old days, 1950s. So the movies that were done in 1950s, Chaudhary Ka Chand and rest of it, they were all done by Sahil Ludhwanvi. Amrita Preetham had a relationship with him, and later she moved out of the relationship and went to live with a very young person called Imtiaz. And somebody asked, some journalist asked him, what is the difference between, why did you leave Sahil Ludhwanvi and why did you leave this thing? Let me come to the basic definition of building. That's what this thing is. Amrita Preetham very clearly said, Sahir was an infinite sky, you know, but Imtiaz is an umbrella. This is what, you know, this actually sums it out. We need umbrellas. That is what we are calling as shelters. You know, we are not looking at the infinite space, and, you know, we need a little space where we can, you know, survive, where we can dine, we can sleep, we can share our dreams and live comfortably. You know, this is what is meant by space, the basic concept of space. And the traditional idioms always talked about time periods, you know, times are changing, styles are changing, needs are changing, and lifestyles are changing. So every form of building sciences, every form of buildings should relate to the times, very critical, very related times. This is actually take back from our old traditional architecture and building sciences. The rootedness in space and time and energy. You know, this is, if our buildings, all the buildings are designed in such a way that it was tuned to the natural energy flow and things like that. You'll be surprised to see this slide, because all my life I've been probably talking against the kind of beliefs and that are being propagated in the name of Vastu Shastra. Oh my God, Vastu Shastra based on a lot of other things. The way Vastu and Vastu is a very, very beautiful concept. You know, it talks about here as a living organism. That's why you have this image of, I'll come to that a little later, Vastu Purusha. You know, it talks about sensitivity. It talks about the mother earth. It talks about sensitive to the soil and mother. And the life force contained within this earth is actually called Vastu. Brain is Vastu. The life force which is contained within is Vastu. So I mean, it's a beautiful concept which is being very, very badly manipulated. Earth is both Vastu and Vastu. I mean, this is a thing that you should take it forward if you really want to get to the traditional idioms of knowledge systems, especially regarding architecture and building sciences. But the present trend is to connect it to some of the beliefs and things like that. Hello? Hello? Hello?
Sir, muted, sir. You can continue, sir.
Yeah, I mean, there's this huge connection between it, which has to be, you know, kind of prolonged further. So why this is the thing? It talks about eco-sensitivity, which has come into the mainframe of traditional systems. This eco-sensitivity is a huge take back for all of us. When you try to believe that the Mother Earth has got some soul in that, some feeling in that, and every building has a soul, then you won't try to hurt the Mother Earth. This is the only take back. Let me tell you, only take back. And why I wanted to show this slide is because it talks about orientation in a good way. It talks about, they talk about beliefs, which I don't subscribe to. I don't subscribe to beliefs, but I subscribe to the scientific facts. We have our kitchens in the eastern side. Eastern side because westerlies are the predominant wind direction as far as Kerala is concerned, because we have a long coastal line, we have the sea on the west. The breeze that comes in from the sea is the predominant wind that is actually hitting Kerala. And when you're talking about putting a kitchen in the western direction, can be disastrous because it can blow in all the smoke, rest of it into the building, which can really affect the basic, flow in the rooms and things like that. So basically, this Vastu, as this thing is talking about sensitivity in terms of design, in terms of managing the land, etc., etc. And it was Vastu Vidya. I will put it in this thing. Vastu Vidya was a comprehensive system. Talk about traditional system because it talked about Bhumi, it talked about her. So that is what we are as engineers, building engineers and architects. We talk about buildings alone, but the sensitivity comes in actually looking at every phase of human habitation. That includes land, that includes Harnya, the house, that even includes Yana, the transportation systems, Shina, the furniture. So it was a complete comprehensive knowledge base that we had. And we had doses of Chitra and Shilpa in that. That is why our traditional buildings look great, because of the Chitra and Shilpa ingredient. What I want to tell you is that this is the knowledge base, traditional knowledge base that we had, and that is still there. And we look up to this study. This is a revival of traditional knowledge base in terms of having Kerala style houses, not really taken the right spirit, but some of the concern is there, which is very, very interesting. And I'm talking about a knowledge system which is completely, which actually encompasses the whole concern about land, building, furniture and things like that. And it's also interesting, and we have been talking about anthropometrics. And the modern building sites talk about anthropometrics. Anthropometrics is the human dimensions, length of the arm, length of your height, and the rest. Everything, every building is actually based on this. We have a new modular dimension system which came in later in 1900 when Le Corbusier, one of the foremost architects of the world, he brought out a new system called modular this thing, and that's when we went for modular buildings, modularity in building design and things like that. But earlier we were talking about human dimensions, talking about your fingers, talking about the span that your arms cover and things like that. A very interesting picture. It talks about angula, hasta, pada. Why this is dearer to us? Because all this is very critical. When you design a chair, when you design a table, when you design a house, when you really raise your hands, if you hit the ceiling, then there's a problem. Everything is the building, all the elements in the building, the measurement sciences have taken its roots from old anthropometrics, if we call way, and some of the nomenclatures are so interesting. And it talks about the human dimensions. It talks about everything, everything is related to the human, face, neck, shoulder, limbs, knees, and feet, all human dimensions, and that's how we related our building to this thing. Now, again, I was talking about Vastu Shastra in a completely different way. It's the sensitivity. I don't look at the belief part of it, but when you start believing that the basic earth on which we are building has a life, then you will not hurt people. This is the basic concept. I do not go at length on it, but the basic concept that there is some life in this Mother Earth where you're going to build a house, and if you can keep that sensitivity right, that you should not hurt the vein part of the building, should not go through the stomach, the belly part of the Purusha, and things like that are very beautiful concept when you really look at it that way. A person is walking away from the religious beliefs. I'm telling you that this concept of Vastu Purusha is something that you should hear, because it talks about the sensitivity, both in design and usage of materials and things like that. This is another graphical representation of Vastu Virsha, talking about sutras and marmas. It talks about sensitivities. It talks about cross ventilation. It talks about bringing light to these things. When you bring light and air into the building, it talks about huge sensitivity and things like that. And another beautiful part of this design, traditional system, is everything has to be functional. Functional utility was the ultimate design criterion, engineering, building science criterion for everybody. The whole building should be functionally very efficient. Not a square foot has to be wasted. Pagyodev, it used to be called as Pagyodev, it talks about functional utility, and it should be good to look at. Very beautiful, isn't it? I mean, that's a beautiful statement. Sugadar stuff. It should be good for the eyes. It should disturb you. When you do something very functional, if you can make it appear like fun, aesthetically acceptable, then you're talking about a beautiful feeling, Sugadarsham and Ramya. Stressful times, this is the only thing that you look forward in your building. A feeling of well-being and contentment. Contentment, I know, is a one-off word. We don't get it in the public space. In the colleges, when you teach students, when you're with your colleagues, you may not get that feeling of Ramya. Ramya talks about in the house. How do you nourish a feeling of well-being and contentment staying there? That particular thing is called Ramya. And now we are talking about even landscaping. This is the basic beautiful thing of indigenous architecture. We are talking about even position of trees in a landscape. When I say Andasara, Bahasara, Sarvasara, and Nisara, it actually talks about the strength of the wood. I mean, if we have very weak trees near the building, and if it falls over when a cyclone comes in, these are called Nisara, means without any inside this thing, what we call as inside core is there. The core, this thing is not there. So, I mean, even traditional building sciences talked about the position of trees, where it should be and what it should be. Another beautiful thing is talking about truthful and honesty and purity. I mean, I'm not being very romantic when I say the ecstasy of observation, intimacy of relationship was very clearly. I mean, these are bungas that you see in the outskirts of Gujarat, and of Maharashtra, etc., Kutch, etc., where the definite definition was to look at house not as a machine to live in, but as a living organism. We talk about value-based building sciences. Where is this gone? Are we being truthful? Are we being honest? Are we being pure in looking at things? I mean, if you look at my own architecture and buildings, you'll see most of them, we don't put plaster outside, because we believe that building is basic brick is a very beautiful building material. It's got a very high compressive strength. Normal burn brick has a compressive strength of nothing less than 30 kilograms per centimeter. Even country burn bricks have this thing of 30 kilograms per centimeter square. That's the compressive strength that we are talking about. So they are relatively strong materials. When I talk about truthful and honesty, I just leave it unplastered. I just, because plastering doesn't really add to the strength of the building. Plastering, civil engineers, plastering out there doesn't add to the strength. It is like putting powder on your face and believing that you are looking better and more beautiful. Plastering might resist some climate, but bricks are actually climate resistant. I've seen bare brick buildings built in 1300, remaining in water in the rivulets of Venice. 1300 buildings that were built in 1300 in water. Half of it is submerged in water. The bricks buildings are still there. So I mean, it's about honesty and truthfulness. It's not about strength that sometimes we plaster and do it like that. And now people, when you talk about traditional these things, new modern architecture, modern building sciences, they talk about downscaling everything. The only this thing I'm telling you, I put it in this thing. We have to look at long-term solution talking about. We have to, there's a habitat agenda before us. We have to look at three things. The building sciences, we have to look at the resources, whether it's land, material, technology. You have to look at ecology and environment, and you have to look at cultural idioms. This is where the connectivity between resources, ecology, and environment is very, very, very critical. We want to contribute to the, welfare of the people, to look at the basic building sector. When I say that, I told about the land, how that should not be. Now, there is an argument saying that land is limited, demand is more. Yes, land is limited. But does it call for multi-storage solutions? I have gone to Tharavi, one of the largest slums in the country, where we are looking at, we need densities. That's very important. That is why probably you are going for multi-story buildings. But with two-story buildings and three-story buildings, can we achieve that kind of a density? Is something which is very critical and very interesting. So the resources are limited, but we can have innovative solutions to meet this thing. Materials and technology, limited materials, optimal use of materials. Technology, we had to look at innovative technologies to minimize the usage of material. Let me tell you that. The technology option should be limited to one of the main parameters of technology is usage of, when we are talking about optimal usage of things, whether it's cement, steel, whether it's any other natural material, if we can conserve some of it, we can revitalize something. This is where we are talking about reusing, recycling, reusing, and retrofitting and things like that. Because all this is talking about resource efficiency. Now, during the disasters, I find a lot of new buildings are being demolished. A lot of buildings that have sustained very minor changes have been demolished. Forget about it. In our own landscape, a lot of old buildings, 50, they call it 50 years old, I call it 50 years young, are being demolished. There's a huge threat to that. We can consume a lot of natural materials. If we can retrofit that building, if we can rebuild that, and we have to discover that vocabulary of reusing and recycling and things like that, because resources are huge, this thing, whether it's the land, material, and technology, which is going to have impact on the building industry. Ecology and environment, I don't have to go at length because I told you very clearly, because every shelter solution will have to be environment sensitive, talking about sensitivity down from either design to the execution. And if it is not culturally appropriate, they will. This is what I'm seeing day in, day out, whether I go to Aralam traditional farm or I go to Attapadi. This is what I see. I mean, our cultural traditions are being very, very badly trampled. And in the name of cultural, I think a lot of ugly buildings are coming and dotting our urban landscape also. Talk about half Kerala style, some tile roof somewhere. And, I call it manipulative architecture. I don't subscribe to that. These are the timeless parameters as far as traditional systems are concerned or modern systems are concerned. Local availability is the only answer, especially during pandemic times. We have come to realize that unless we use the local skills and locally available material, you cannot go on with your buildings. This is something that should bring back to the main template of this thing. These should be the first criteria for selection of materials and technology. Local is the mantra, my dear friends. And you have to look at the insulation, use. I don't want to go at length. This is basically how the framework. But the basic take back from the traditional system is that these things were right in position when they talked about, promoting a building vocabulary for the traditional building. They built only with locally available material. They didn't bring, people from Gujarat or people from Orissa to build our houses. They built with local asaris and local masonries, local skills. And it became a manifestation of their dedication and sincerity. Cost was obviously less because we didn't bring marble from Rajasthan. What is it? And also another beautiful thing about traditional houses, it is all insulating. We are now using contrived systems for getting houses insulated, air conditioning, things like that, which should be completely taken away from our building stream, because it talks about very bad health indicators, talk about contrived air quality, which is very indoor air quality is very badly. This is why if you somehow get COVID and go to the hospital, first thing that they ask you to do is to open the windows, stay in a very well ventilated room and things like that. And it also talks about energy efficiency, eco-friendliness and this thing. Then this is all the traditional materials, mud, lime and bamboo, mud. I've built last probably 15 years, I've been building only mud buildings. I mean, upgrading the technology to stabilized earth block and things like that. And Kerala, I mean, for your information, let me tell you, has the richest lime deposit in the world, richest buildable lime deposit in the world, just across your this thing. In Kottayam, in Alappuzha district, where Rembrandt Kyle actually spreads its wing, they're the richest buildable lime deposit in the world down there. I still remember when I was a very young student, living in this area, people used to collect shells from the lake bed, take it to the shore. The women used to grind it, and the old people, the local people used to cart it by bullock cart to local markets, thereby creating a number of employment opportunity at every level. Lime has become a poor man's building material, and for civil engineers, lime and cement are basically the same thing. If both of them talk about calcium ingredient, it has got structural limitations, but if you put back all the little materials that people have been using, these for centuries together, we can mainframe them. We are talking about local efficiency. We are talking about eco-sensitivity. We are talking about a lot of things that really will go through this thing. Bamboo, the tensile strength of bamboo is, as good as steel. So in at least limited these things, you can use steel as a, very viable building material. I built earth buildings. I built the largest earth building in the world, talking about 600,000 square feet in Bangladesh, where, I mean, bamboo, I'm actually using it as symbols for promoting a dialogue. If earth can be used to build a big building, bamboo can be used for multi-story, usages, then it raises questions. It talks about the critical questions that we have to answer in terms of sensitivity, talking about availability, cost, workability, local skills, aesthetics, energy friendliness, eco-friendliness, and enough strength. Now, bamboo, does it have enough strength? What are the enemies? What are the enemies of earth for it? I mean, dampness is an enemy. How do you protect dampness from getting it? You have technology solutions. You have technology solutions promoted by institutions like CBRI, Central Building Research Institution. Technology is vetted by CERT, Structural Engineering Research Institute in Chennai. They all talk about earth as a very viable building material, which can be used in many forms. That's the beauty of it. It can be used as a COP construction, Adobe construction, COP construction, rammed earth. There are plenty of options, my dear friends, to build even multi-story buildings. I'm saying it because my building, Francis testimony, the big building that 5-story building that I built in the Brahmaputra plains, floodplains of Brahmaputra in Bangladesh, still remains 600 square feet, 600,000 square feet of built-up area in Bangladesh, still remains as one of the largest buildings in the world. So, I mean, when I talk about earth and bamboo, I'm going to talk about alternate materials, and probably I will, and the rest of it, the scale, dimension, how topography has been manipulated and this thing, how responsive were traditional systems and how spaces were done, how open-ended forms were accepted in the symbols and meaning. And even, the left, you see this Thoda house, how traditional, these things were. We have lost that sense of building sciences. Local people used to build these parabolas, without much difficulty. These are parabolic structures. Now we use engineering, simulations. We have to simulate model to do this kind of precise parabolic structure. The Thodas, the traditional, Adivasis from Nilgiri Hills, used to do it with such a thing. And this is very disturbing because we knew the technologies, We knew about how to build it. We had mathematics with us. And, you know, why, when I'm talking about traditional idioms, I'm talking about conservation, I'm talking about reuse, and I'm talking about recycling. I'm talking about the concerns. I'm talking about the concerns, and how do you actually, I mean, I'm an architect basically, and what are my answers? This is how I build, you know, how, when a topography comes, that is a little quarry pit that I had converted a large 1 acre water harvesting structure. This is buildings built on a mountain in Munnar Engineering College, traditional, you know, huts in Mahan, Madhya Pradesh. This building that I built for Rahul Gandhi at Raebareli, expressions of innovation. The top two slides talked about disaster interventions, you know, how culturally appropriate, how timeless factors, how gone into these kind of, how look at the recycle, look at the reuse. My buildings, the pictures, this is my own office building, talk about adaptations and innovations. It's a 6-storied building in mud, and these are some of the interiors we've taken 10, 12 years back. I've not updated it. This is still there, and this is the space that I'm using as my. Now, when I talk about these kind of materials, one of the questions that come before you is how acceptable is the look and how durable is the look. My buildings are my own answers, my dear. When I talk about bamboo railing, 15 years, growing now. Look at the bamboo railings and the vocabulary of building materials. How do you main phrase? This is my main reception, you know, the terracotta tiles. I mean, it's all architecture combined together. And I will probably wind up at this because it's 10:10. I will take a few questions. If we have questions, and then you can move on to the next presentation. Thank you very much for your kind listening. Somebody was, if I heard it right, you know, somebody was questioning, somebody was mentioning about the presentation of England. I really welcome critical comments also onto this, and thank you very much for the time. Whatever little questions in another 10 minutes, whatever little questions that you can ask me about traditional systems and the linkage and connectivity to modern building systems. I'll be only happy to answer. The only thing that I want to tell you is that sustainability was the criterion for traditional building system, and that concern will have to be brought back to modern building system if you want to save the mother earth from further deterioration. Thank you very much for your kind listening, and if you have questions, I'll take that. Otherwise, I'll say goodbye to you. Moderator, please take over.
Yes, sir. Thank you.
Thank you, sir.
Yeah.
Thank you for the very informative session. May I request our participants to interact with our expert? Participants, if you have any queries, please interact with our expert. You can use chat box also. It is open, but I don't think there are people. The questions come and come.
Yeah.
Participants, please ask.
If you don't have questions, I will say bye to you. Thank you very much for the opportunity. Mr. Matthew?
Sir, one question is there. Sir? Shankar
Yeah.
sir?
Yes.
Sir, how durable it is, the bamboo structures, for up to what extent we can use this bamboo structures in our Kerala? I think it is locally available. Materials is locally available. But nowadays still we are constructing the structure in the that is using the RCC or steel structures. So
yeah, I mean, let me just respond to your question. You know, I'm trying to talk about mainstreaming bamboo and earth for two reasons. It should, you know, whip up a dialogue, you know, at least among us, you know, because these materials are touted as non-stable, not strong materials. And what are the technology upgradations that can be brought into uh, mainstreaming materials like bamboo, like earth? A lot of technology interventions have happened in the last 30 to 40 years. In the sector of bamboo, we have a huge bamboo mission, you know, being led by Government of India, and there are a number of bamboo initiatives that are working in position, even in Kerala. I mean, it's one of it is called Kerala Bamboo Development Corporation. The rest of it, my this thing, they are all upgrading the quality of bamboo. Is vulnerable in certain situations. You know, for instance, insects can attack it as long as it is moist. So there are many systems by which you can take out the moisture from the wood, you know. There is vacuum chamber. You just pass the log through the chamber and it gets dried. So this is one way of doing it. And if some insects are there inside this thing, I mean, it can finally eat into the basic stem and that can weaken the structures when you're especially using it as tensile members. How do you do that? We inject materials like some chemicals like arsenic fluoride to kill the insects inside. You know, it goes through a process. It goes through a process, a kind of a process wherein we actually inject these kind of anti-insecticides into this thing so that it becomes termite proof, you know. So this way, we are trying to upgrade the quality of bamboo in the building industry. Now, each bamboo, each member has to be tested for its tensile strength. You know, I'm actually trying to do it in all the ways. Bamboos for foundation, bamboos for plinth beam, bamboos for walling, bamboos for roofing. I mean, that is how you should actually promote a material. I mean, it's not halfway through. I mean, now there is a trend. I mean, I'm at least in Kerala where you see concrete structures and bamboo infills. Yes, as an architect, I agree to that. That is some step forward. You know, instead of traditional bricks or other cladding materials, we are using bamboo as a cladding material, as an infill material. Well, I mean that is half the battle won. But the stress, the challenge before us is to use it as a mainstream building material, as a walling material, as a roofing material, and as a finishing material. I mean, bamboo actually can be used in all these. I mean, if you go to places in the Far East, like Indonesia, China, Laos, Thailand, Philippines, Vietnam, you'll see this wonderful usage of bamboos in this thing. Why bamboo should be touted as a basic building? This thing. One is it's disaster resistant. I don't say it is not only disaster material, it is basically disaster resistant material. This is the vocabulary of buildings in Assam and the Northeast state you are seeing. Most of it is all bamboo structures tied up. You know, when the vibrations, when the earth shakes, it shakes with the earth. You know, it's not against the earth's forces, the forces that actually hit the building. It swings along with that, and the bamboo structures now fail even in severely affected disaster situations. So these are some of the concerns that you should address as an engineer, you know, as a civil engineering faculty. How you could mainstream it, you know. Yeah, my knowledge as far as engineering part of bamboo is very limited because I'm basically not an engineer. Now, I have built 3-storied, 4-storied uh, buildings using bamboo as a basic building material. Now, when I say basic building, when I want to make a beam, the engineering college don't support me in testing the strength of the beam. Instead, what I do is I put it as a portal, you know, with simply supported portals. I put sandbags on top of this till it fails. Then I know the weight at which each member fails. So when then I put another reinforced, it is a trial and error, painful weightage for, making it structurally, strong, and like any material, any technology that I promote are structurally validated. I don't promote which is materials that are less strong and less durable. No, never. When I promote a material, I promote with such clear engineering convictions and with clear validations that ensure the strength and the durability of the material. And there are many solutions to these two stresses. Now, tensile strength, as you know, is very high. So as engineers, especially teachers and others, we should actually look at this tensile strength of bamboo and how you can compare it with tensile strength of steel, and try to support the usage of bamboo splits. It can be done in many ways. I don't want to go into details. You can split the bamboo into 6 pieces, and using this bamboo split, can it be used for, I've used it in hundreds and thousands of buildings as main reinforcement and secondary reinforcement in limited spans. I've not used large spans, talking about more than 20 feet and things like that, but limited spans, 4.2 meters I've used it. 14 feet, that is what everybody else does. Even steel, if you go beyond, especially in residential construction, if you go beyond 14 feet, you go in for a different structural system, talking about more columns, beams, etc., etc. So this is where, my whole question is how to mainstream a locally available material, looking at the strength characteristics, looking at local employment, looking at local opportunities, and having a beautiful vocabulary for the buildings. Bamboo buildings, as you know, look very beautiful, especially the tourist structures. If you have a bamboo house, that sells fast. That goes fast. Whatever be the rent part of it, people want to stay in bamboo house. That's the fascination of bamboo. Is a very beautiful, architecturally acceptable building material, and that's why that is how we mainstream it. But thank you for the question. You are right. A lot more research has to go into the treatment systems and the rest of it. They are not popular in Kerala. We have a good resource base in Kerala, especially in Wayanad and those mountainous areas, even in Trivandrum. But if you want to use that resource, we have to strengthen the research and development this thing, and the engineering colleges have to develop that. And I have come to know that there are bamboo research centers in few colleges, including one in Barton Hill Engineering College in Trivandrum. And if people are actually take more interest, it will really have a nice future for them. Thank you.
Thank you, sir. Few more questions are in the chat box.
Sir, Shankar sir.
Yeah.
Sir, I have a question to you. Sir, I am very much interested in constructing my home in mud construction, using mud. But I am very much confused because this mud construction is not much familiar in Kerala. And I am that is why I am very much confused in its durability. And also, I want to know the square feet rate in mud construction.
Yeah. Let me answer that. I've been a promoter of, practitioner of these technologies for a long time. Each time when I start promoting a material, these are the same questions that just for information, I've been thrashed. I've gone through physical assaults, for promoting materials like bamboo and mud, because, it goes against the interests of the society. It goes against the vested interests of some building, material manufacturers and things like that. I don't want to go at length with that, but yes, ma'am, definitely when you start looking at new materials, durability and life of the building can be. Let me put it in another way. We have technology upgradations. Now, we have heard of interlocking mud blocks, what we call a stabilized mud blocks that are now, I'm the first promoter of that technology in Kerala, and it has become very popular in Kerala, and I see thousands of buildings, not only my building, several others are using that as a basic building material. Now, how do you ascertain, as you know, for the building material, basic walling material, what is it that you're looking for? You're looking for compressive strength of the material. Why do we take burn brick? Is because the compressive strength is relatively high. Even country bricks will give you a strength of compressive strength of nearly 30 kilograms per centimeter square. Adobe bricks, pachakata and varile, which are not burnt, I mean used at a rural level. Even those adobe bricks, unburnt mud bricks, have a compressive strength of nearly 10 kilograms per centimeter, which is actually good enough to take the weight of a two-story building. I'm saying it with conviction, I'm telling you. Because every engineering calculation, you have a factor of safety. You know, we call it factor of ignorance. I'm telling you, ma'am, because I know the strength of the material, durability. Because I myself is a good mason. You know, I work with my hands, and once you get that intimate feeling with the material, intimacy of you know, the properties, engineering properties, you become more confident. Now, let us not look at that. Strength is assured because there are several upgradations to make it strong. The technology upgradation to make it strong. Even design interventions are there to avoid these climatic interfaces that might make the materials, you know, vulnerable. Now there are other phases. When you really look at it, there are other things like termites. Our mothers, our forefathers have actually given us a huge technology of mixing lime with mud so that it becomes resistant, completely resistant to insects. You know, this is the beauty of our traditional system. We don't have to go in for chemicals. There are ever so many chemicals in the industry. I don't go for chemicals and adhesives. I go for traditional building systems and knowledge base. You know, you add lime to that, it becomes this thing. And for avoiding dampness, there are, like I told you before, non-erodible mud plaster is there. There are several design elements that will prevent water from lashing on a building and preventing this thing. I'm saying with conviction because I'm talking to you in front of sitting inside a 6-story building, remaining on the top floor, and the only thing is that, ma'am, you have to look at probably some of the videos. You can Google my name and find out a few buildings that I've built my own house, Siddhartha, where the roof is also mud, no reinforcement, only mud. I mean, just look at it. I don't want to go into the details of that, but mud can be used even as a roofing material. And mind you, 2018, my house was inundated by floods. Water came into my house and nothing happened. Water actually went over thousands of my houses which have been built using mud, but nothing, not even one building has sustained major damages. You know, technology has become perfect. Stabilization, that technology has become very perfect, very good. Compressive strength is around 40 kilograms per centimeter square. Durability is very sensitive technology, very eco-sensitive technology, because we are not using sand and cement for infills. It breathes, insulating. What else, ma'am, are we looking at? And the last question is very, very sensitive. You are talking about per square foot rate. Let me make a comment on that. I don't want to reel out the per square. It is definitely cheaper than any other conventional system of walling, because it's mud, it's almost a no-cost material, no mechanical, only mechanical process, no burning, nothing. Energy, this thing, for not only for the cost efficiency of the building, but for an environmental cost, for social cost. You'll have to promote these kind of materials. Thank you very much. You can Google and find out about this thing, and I am always available to answer your queries. Thank you.
Okay, sir. Thank you. Thank you very much.
Sir, I have a question.
Yeah.
Sir, regarding the flood that has affected widely Kerala, I am also residing in a flood-prone area. So I wish to know the components which you would suggest for building, starting from the foundation. So which will prevent it from getting highly flood affected.
You know, if you're actually staying in a flood-prone area, there are two things. You have to take the building above the flood levels. That's one thing. How do you make it, you know, how do you start the building from above the flood level? It is obviously going for raised foundation. Probably the best solution, as we are trying in Kutanad and other areas where that is a calendar event, is to go for stilt foundation. On, you know, you have the basement on stilt, foundation basement on stilt. Stilt means you take it above the flood watermark and then start building on that. for stills, you can use these local materials and local technologies and bamboo reinforcement, things like that. Take it above the flood levels, and then you are safe. Then, what are the water resistant features that is? It's about the building. Let me tell you this. I mean, it is very critical for understanding disaster dynamics in engineering. The impact of a flood and the earthquake actually are very similar. The impact of the, let me make that statement, the earthquake and the floods on the building, it's almost similar. So when you build buildings, whether it's a flood prone area or earthquake prone area, you have to make a monolithic, homogeneous building. You have to bind it at different levels. You know, you have to have a plinth beam, you have to have some connection at the sea level, you have to strengthen the sides of the doors and windows, you have to have a lintel connection, and the corner connection right from the foundation to the roof has to be there at corners, because these are, whether it's floods or earthquake, I'm telling you, the dynamics is the same. The corners of the buildings are very vulnerable. It can get split, and that is how some of the buildings collapse. So those things will have to be really taken care of, and you have to build a disaster-resistant building. I'm sorry, I'm not able to go at because I've been a chairman of the committee to frame this disaster meeting specifically. I go at length for probably another 6 hours on the disaster-resistant structures, because I've been very deeply involved in disaster mitigation activities for the last 3 decades across the world. This is my brief response to your question. Thank you very much.
Thank you, sir.
If you will permit me, I'll have to leave because it's 10:30. Mr. Matthews, will you?
Okay, sir. Let me welcome Professor Appu P for the vote of thanks. Appu, sir.
Good morning, one and all. It is my honor and privilege to propose vote of thanks on this occasion. I, Apu, Assistant Professor, Department of Civil Engineering, College of Engineering, Kidangoor, extend a very hearty vote of thanks to our eminent resource person, Padma Shri Dr. G. Shankar sir, for sparing his valuable time with us and for enlightening us with your knowledge on traditional idioms on building design. This session enriched with the topics that describes energy efficient buildings, climatic approach, then about the organic architecture, then organic positions of the buildings, then 3 idioms, that is space, time, energy. Also, he describes about the Vastu and the Vastu Shastra, Vastu Purusha Mandal, all these things, and the basic 3 principles of design. Then he describes the advantage of this using these mud constructions, bamboo constructions, etc. All these things. Okay. So on behalf of Civil Engineering Department CEK, once again I thank Padma Shri Dr. Shankar sir for accepting our invitation and sparing his valuable time with us. Thank you, sir. Thank you so much, sir. So dear participants, it's a time for break. So next session will start at 11 o'clock.